Hello, good evening to everyone. In this video, we are going to be looking at how to solve inequalities. Now, I'm just going to take an example where we are going to be solving the inequality, the square root of 2 minus x less than or equal to 1 minus x. Now, the very first thing to do when you're solving an inequality is to find the domain of definition of that inequality. Now, the domain of definition of the inequality in this case are the values of x for which this inequality is defined. Now, for you to find it, what you do is that you find the domain of definition of all the functions present, and then we take the intersection on the number line. Now, in this case, we have two functions. We have the function 1 minus x. So we find the domain. 1 minus x is defined for x in the set of real numbers because it is a line. Now, next you have the square root of 2 minus x, which is defined. So this square root is defined for 2 minus x being greater than or equal to 0. Why? Because for the square root function to be defined, the interior must always be positive and can be 0, since you are dealing with a set of real numbers. So in this case, if I divide all through by the negative sign, I'll get x minus 2 less than or equal to 0, meaning that x is less than or equal to 2. Now, since we need to find the domain of definition of this inequality, we now go to the number line. We plot the two domains. The first one is x in the set of real numbers. This is just a set of real numbers. Nextly, x is less than or equal to 2. It means I put at 2 I enclose, and then I take everything going down. I shed, that's x less than or equal to 2. Now, since x less than or equal to 2 is a subset of the set of real numbers, then the intersection is just x is less than or equal to 2. So it means the domain of definition of my inequality d is x less than or equal to 2. That's my domain of definition. Now, that's the very first thing to do. Now, since in this case we are involved with linear and square root functions, the only thing we can do here is to square both sides, and there is a condition for also square both sides. Both sides must be positive. So in this case, we see that you have the square root of 2 minus x on the left hand side. On the right hand side, you have 1 minus x. Now, both sides being positive is not in all cases, actually, because in some cases, if both sides are negative, you can see square both sides, provided the inequality is always true. Now, in this case, we can read the two sides. Now, we know that the square root of a function is always positive. Let me just try to draw the graph of the square root of x. That's the square root of x. It is increasing and always positive. So here is the square root of x. So it means that the square root of 2 minus x will be always positive. Now, what about 1 minus x? It is positive or negative depending on x. If x is a number that is bigger than 1, when you take 1 minus it, is going to be negative. But if x is a number that is less than 1, when you take 1 minus it, is going to be positive. Now, this inequality is saying that, for example, let's take the first case where 1 minus x is negative. This inequality will be read as a square root less than a negative number, which is impossible. So you see that for also square both sides in this particular case, they must be positive, because if this is negative, then the square root, which is always positive, can never be less than a negative number. Okay, so if this is positive, then we have a square root which is positive less than a positive number, which is true. All we need to do is to find the values of x for which that is possible. So it means that to square both sides, in this case, they must be positive. Now, since the square root function is already always positive, we just need 1 minus x to be positive for us to square. So it means 1 minus x is greater than 0, meaning that x minus 1 is less than 0, meaning that x is less than 1. So that's a condition for us to square both sides. Now, we keep it. Now, when we square both sides, when we square the left hand side, we just get we get 2 minus x less than or equal to, when we square the right hand side, we get 1 minus x, all that squared. Now, this means that 2 minus x will be less than or equal to 1 minus 2x plus x squared. Now, we can take everything to the right hand side. We get 0 is less than or equal to 1 minus 2x plus x squared, then minus 2 plus x. We subtract 2 and then we add x. Now, it means that 0 is less than or equal to x squared minus 2x, which is this, plus x is minus x, and then 1 minus 2 is -1. Now we can reverse this as x squared minus x minus 1 is greater than or equal to 0. Now we start by finding the critical values and then we deduce the solution set. I'm just going to use a shortcut. So my critical values, so our critical values, we have x is equal to, we just use the quadratic formula, you get 1 plus or minus the square root of 1 squared minus 4 into -1, then all divided by 2. So you get x is equal to 1 plus or minus the square root of 5 divided by 2. So our solution set, because you are solving an inequality, our solution set is going to be, since the sign here is greater than or equal to, then we can deduce it already. So x will be less than or equal to the small number, which is 1 minus root 5 on 2, then union x is greater than or equal to the big number 1 plus root 5 all divided by 2. But now for us to arrive at this response, we have the condition, which is x should be less than 1. That's a condition. So it means that we take the intersection between these two values with x is less than 1. So we come to the number line. Now we need to get the approximate values of 1 minus root 5 on 2 and 1 plus root 5 on 2. Okay, root 5 is approximately equal to 2.25. In subsequent videos, I'm going to show you how to find the square root of numbers without using a calculator. So 1 minus root 5 is approximately negative 1 point something divided by 2 is going to be negative. So it means that here you have 1 minus root 5 on 2. Now what about 1 plus root 5 on 2? Is it greater than 1 or is less than 1? Root 5 is around 2.25. When we add 1 to it is 3.25. We divide by 2 is 1 point something, so it's greater than 1. So it means 1 is going to come here, then 1 plus root 5 on 2 is going to come. Now the solution set of this inequality is saying that x is less than or equal to this, and then x is greater than or equal to this. But for us to arrive here, we use the condition that x should be less than 1. So it means I open at 1 and then I come down this way. So this is where they intersect. They don't intersect in this region. So it means that the acceptable value is x is less than or equal to 1 minus the square root of 5 divided by 2. But we have not ended. Why? Because we still have our domain of definition to talk about. Now the domain of definition says that all values of x that will satisfy this inequality, that's all values of x satisfying this inequality, must be less than or equal to 2. So we come back again to the number line to get the final. Now this is our sub response. Now we know that it is negative, so 1 minus the square root of 5 divided by 2. Now 2 is around here. Our response says that x is less than this value. Now the domain says that all values of x must be less than or equal to 2. So you see, this is the region in which they intersect. So they say intersect here. So this is our final answer. So this is our final answer. Alright, so guys, that is all about the video. Make sure you subscribe to the channel. Thank you.